Hey guys, chapter 12, weathering and erosion. This is an exciting one because when we think about how our world works, it's constantly building and destroying, breaking down. And so what we're going to do is talk about how those processes work. First thing I want to talk to you about is weathering. Now, weathering is kind of an interesting statement. What we're doing is we're talking about the breaking down of material. How does it weather? How does it break down? Well, there's two main types of weathering. The first type is chemical weathering. So, for example, if something reacts with a chemical and changes, when we think about chemical weathering, we think about one chemical interacts with another chemical and it changes the makeup of those two chemicals. In other words, it changes to something else. But then you have physical. Physical weathering is basically a changing of a substance, breaking it down. And what we're talking about is generally going from larger parts to smaller parts. Very simple. Now, when we think about these different types of things, the first one I want to talk about is mechanical weathering. What's a mechanical weathering? Something is producing or working on rock or an area in the soil. It's physically breaking it down. So mechanical weathering. Example: if I'm pressing on one side of a rock or if I'm hitting a rock with a hammer, right? So I'm physically doing something. I'm mechanically changing it. When we talk about an agent, we talk about things that make this happen. So a good example is why Illinois roads are awful, right? Water gets in the crack, it freezes, it expands, it cracks. And so as it does, ice is a mechanical weathering agent. Plants. When I was a kid, I used to race BMX bicycles. I'm racing bicycles, and then we'd go in town and find those sidewalks where the tree root grew underneath the sidewalk, and it pushed it up. This is a agent of mechanical weathering. This is a material that's pushing up the sidewalk. Animals burrow all the time, dig out stuff, gravity, things fall. Running water is an incredible agent of mechanical or physical weathering, right? Wind. Anytime we see, this is why, plain reason why you don't eat a peanut butter and jelly sandwich at the beach, right? Wind is picking up the sand, it's hitting it, right? So the first type that we'll talk about, again, is exfoliation. And when I think about exfoliating, I think about elbows with skin cells or your feet or whatever. And so all of a sudden you go, okay, I'm going to wear away a layer, exfoliation. This happens when we have giant pieces flaking off. Very simple. In granite or wherever, these long pieces come off. I'll show you an example of that. The next one, I think I already talked about the ice wedging, where it's freezing, expanding, melts, fills in a little bit more, freezing, expanding, and so it cracks. Ice wedging. And again, we see that with roads, we see that with cliff sides. This image right here, this is an image of rock that was on the side that broke off of a cliff. And you can see here's the cliff: freeze, thaw, expand, crack, drop, gravity, break, right? So this is a good example of ice wedging. Organic activity. Now, here's the thing I didn't talk about with organic activity. A plant goes underneath the sidewalk, expands, gets bigger, cracks it. Great. But the other thing is plants have acids in their roots, in their outer membrane. And so as those little roots get inside that stuff, they produce acids. And as they're doing that, yes, the physical aspect of expanding, it cracks it, but then there's also a chemical that I'm going to talk about. Animals burrowing into holes. This is big at the golf course. If you go out to the golf course, they're always you've got skunks and possums and raccoons constantly looking for grubs, tearing stuff up. Well, the moment that you get air or a pocket into that stuff, it now exposes it. The moment that you expose it, guess what happens? Air gets to it, gravity, water, wind, wave, etc. Right? Abrasion. This is exactly what it sounds like. Anything colliding with another. I remember as a kid riding motorcycles with my cousin, and I was the second person on the motorcycle, and he would pop a wheelie, and every once in a while I'd go off the back end, get an abrasion on my backside. Yeah, that hurt. Anyhow, abrasion when you scrape or break as it's going over the top of something. So that long fall off of this cliffside, it breaks. It's abrasion. Okay. Here's that exfoliation taking place. Interesting, this here used to be one whole piece of rock, but you'll see that it's missing. And so as wind blew through there, picking up dirt, it is sandblasted it. There's a good example. Sandblasting. When we talk about sandblasting, great point. Uh, um, it they do that on paint and cars, etc. Okay. This is what we call a talus slope. A talus slope. And this is the freezing, thawing, freezing, thawing, freezing, thawing. I don't know why I've got my hand up, but I do. Anyhow, so when you look at this, basically this freezing thawing drops off. This is a good example. So this is my family and I on vacation one year in Colorado. We're riding trails in Colorado. This is that freeze thaw crack drop talus slope. And if you notice, I stopped to take a picture. And where did my family go? They left me. But if you look, it continues on, right? And so what somebody did is they came here and they made a trail along this rock shelf. And this is talus slope. Okay. This is ice wedging, right? So this rock's about the size of a car. Water goes in here, freeze, thaw, expand. And so we have, again, that ice wedging. Organic activity. These roots get in here. And again, I mentioned already, there's also some chemical going on. The organic, it spreads apart, breaks apart, expands the roots. Away you go. There's a couple videos that I put in there that I think you should watch on mechanical weathering. Now I'm going to get into chemical weathering. The first one we'll talk about is hydrolysis. Hydro means water. Lyse means to split. So water splitting. So when water, it rains, water goes into the soil, it changes chemically the composition of that soil. So in other words, here's a good example. If you have feldspar in your ground, it will be changing your soil just by putting water in it to clay. And so when we deal with clay, what are we doing? We're taking those particles and bringing them together chemically. Now, leaching is a little bit different. Leaching is when you remove water. So by removing the water, again, you're transferring the particles in that area and dispersing them into the material. So for example, when I use leaching, I think about coffee. Coffee is one of those things where you leach the coffee out of the coffee bean that's been ground up, and then it goes into the water. Again, leaching a little bit different than hydrolysis. Carbonation. Carbonation, when our rainwater is slightly acidic, it then gets and breaks down material. Now, why am I bringing this up? Well, it's slightly acidic because we have carbon dioxide in the air. Carbonic acid forms with water mixing with carbon dioxide. And so as a result, we get this slightly acidic rainwater. When it comes down, it then does damage on material. And so all of you have seen the tombstone that's in my room or the gravestone project that we're going to be doing. The tombstones are slightly dissolved. Well, how did that carbon get in the atmosphere, that carbon dioxide, carbon monoxide? Predominantly human activity, the burning of fossil fuels, the burning of material. Okay. Oxidation. We have many types of oxidation. When we talk about iron, it's called rust. When oxygen mixes with the iron to create iron oxide, now you have rust. Copper will do the same thing. And so we see this breaking down as a result of that. Let's see. Acid precipitation. I already kind of talked about this with carbonic acid. Again, acid precipitation is slightly acidic rainwater. It breaks down rocks. We'll talk about buildings and tombstones as well. Plant acids, when we talk about plant acids, when this again, chemical weathering, what's happening is the roots and the little stem pieces of the plant grab on as producing an acid. So these mosses, these lichens, these other plants start to break down the rock. Okay. Here's a good example. This is chemical weathering as a result of acidic rainwater. Now, didn't help that it also has abrasive taking place through sandblasting. And so when you see these different images, yes, water has dissolved it, but the air has blown sand too. These statues, this is 1908, pretty crisp. 1969, no face. Jesus no longer has a face here. Unfortunate. It's gone. This gargoyle, this is on the side of a building where the gutter comes out, used to have just a little mouth. Now he's spewing water, right? And so pretty good image. If I look at this is called Cleopatra's Needle. Here's the question. This is an obelisk from 3,000 years before BC, right? So it's been around for about 5,000 years. It's in New York City. Egypt gives it to New York City in the 1800s and says, you are our sister, New York City, to tie everything together. When they brought it there, it was recognizable and readable. Let me show you what it looked like when they brought it there. I don't have a, here's 1870. You can read what's on the side of it if you know hieroglyphs, right? Or hieroglyphics. And then in 2008, that's what it looked like. And this is what it looks like today. You can barely read it. So the question is why? Why is it that way? Well, it's that way for one reason, is because we have acid or slightly acidic rainwater. We have also pollution in the air, and then we have freezing and thawing. And so human activity has really caused this. But why didn't it break down for 3,000 years in Egypt? Well, that's simple too, right? So you have this dry, ultra hot climate. It's not breaking down rock. When you change temperature, freeze cold, freeze thaw, hot, freeze, right? And then you have humidity, high humidity, low humidity, high humidity. Then you have pollution in the air, no pollution in the air, right? So the acid, the high humidity, the low humidity, the temperature change. These are things that causes weathering to take place. Here's that leaching again I talked about. If we have it rain, those materials leach down and form clay because those minerals leached out of the soil. Oxidation, I think, is pretty straightforward. Oxidation rust, right? Talked about acid rain, sulfur dioxide, sulfur trioxides. They're in the air. It then comes down, the rain comes down. The sulfuric acid reacts, or hydrogen sulfide reacts, or the nitric acid or nitrogen sulf or nitric acid reacts. Almost said it wrong there. Sorry about that. Same thing here. Organic activity. Somehow this plant wedged itself in this rock. It then expanded, cracked. These lichens are doing the same thing. Okay, so what I want you to do is take a look at the videos I put in the classroom. I think that'll be helpful. Overall, I think you guys will get it. I appreciate you for all you do. Thank you so much, and have a great day.